okay, on alkenes. Okay, now alkenes, okay, they are known as unsaturated hydrocarbon because they can form new bonds. Okay, and the general formula is CnH2n. And the first reaction I think we need to know about alkenes will be, okay, cracking. What is cracking? If you take a large hydrocarbon and you want to break it down into small hydrocarbon, that is what we call as cracking. Cracking can be done in two ways: catalytic or using high temperature. We call it thermal. Okay, but they didn't discuss in detail in your textbook, so I just put it over here. There are two ways to do cracking, either by using catalyst zeolite or by using high temperature. So generally, what is cracking? So if I write down the equation, for example, okay, let's C10, for example, C10H20. If I want to break it down into smaller parts, okay, let's say I'm going to break it into C5, okay, C5 what? Okay, so maybe let's say I'm going to get alkene, for example, okay, so C5H10, CnH2n, yeah, and then left with how many carbon? So still 5 more carbon, and H is going to be still 10. Okay, so it means it's going to be, you are going to break it into two pentene molecules. Okay, two pentene molecules. We can do the same thing. Okay, like for example, if I have C10H20, I want to break it into three parts. For example, one is going to be C3, another one is C4. Okay, and then the last one, let's say I'm going to talk about C3 again. So I can what we need to do is just to play around like maths. Yep, so it's going to be H. Okay, so maybe I want to form alkene. Okay, so double, so H6. And then here maybe I want to form another alkene also. Okay, so H 8. So I know 6 plus 8 is already 14. So left with 6 more. So H6. Okay, this is how you balance. Okay, so this one I'll just leave it over here. Cracking is going to be breaking it into smaller carbon chain. Yeah. Now the reactions, generally alkenes and alkane, they will undergo combustion. The same thing. Combustion, you can have complete combustion, you can have incomplete combustion. Complete combustion will give you carbon dioxide and water. Incomplete combustion will give you carbon and water, or carbon monoxide and water. Important is to learn how to balance the equation, similar to what we have learned yesterday. Okay, so this one I'll skip. Now, since, okay, this is going to be unsaturated compound, okay, because of the presence of carbon-carbon double bond, okay, there is going to be sigma bond, and there is also going to be pi bond. The presence of pi bond increases the electron density over there. So it means there's a lot of electrons in the double bond. So if you have a lot of electrons, they will attract the electrophiles to come. Okay, because electrophiles, they love electrons. Okay, so the electrophiles will attack the double bond. Okay, because they love the electron. So that's why this reaction is known as electrophilic addition. Okay, so electrophilic addition, so we have learned in the in alkane, sorry, in alkane we have learned free radical substitution. So now we are learning about electrophilic addition. So just stay with me. You don't get confused with a lot of stuff yet. Okay, for now, we only learned about free radical substitution and electrophilic addition. Later, we will learn more. Okay, for now, only two. Okay, only two. And this electrophilic addition, we have 4 types of reaction that can happen, which we will discuss now also. Okay, reaction with H2 hydrogen, so we call it hydrogenation. Okay, if there is another name, but it's fine if you mention it addition of hydrogen, still okay. Okay, reaction with steam, okay, we call it hydration, but it's still fine to represent this by addition with steam. Addition with hydrogen halides, and addition with halogens. So we are representing the hydrogen halides can be HCl, it can be HI, it can be HBr. Halogens Cl2, Br2, and I2. Okay, so all this will be we will discuss. And then there are other reactions on top of that. Okay, on top of combustion, on top of electrophilic addition, you are going to have oxidation. We will not discuss this today. And also addition polymerization. We are not going to discuss it today also. Okay, so today I'm going to just focus on the electrophilic addition. So 8 more minutes left. Okay, so here, okay, you have a look at the 4 reactions that I mentioned earlier. We are going to look at the conditions and how to write equations first. Okay, so the conditions, okay, when you are reacting, let's say I'm going to react with ethene. Okay, I'm just going to write it in this way. Hydrogen, I'm going to represent it this way. And what is going to happen? Okay, the double bond is going to be broken, and this bond, okay, they are going to be replaced by one hydrogen here, one hydrogen over there. Okay, this is going to be addition reaction with H2. Now, how do we do this? Okay, the condition must be with the presence of nickel catalyst and 140 degrees Celsius, and you need to memorize this. Okay, this one must be memorized. Nickel and 140 degrees Celsius. So the next one, okay, is going to be if you have, okay, similar example, and then I'm going to react with water. Okay, better if we can represent this using HOH. So if we represent that in that way, okay, let me share the screen again. Okay, it's quite laggy. You can see it over there. Okay, carbon-carbon double bond. Okay, and then with HOH. So H2O, I'm going to change it into HOH. And what will happen? Okay, so the double bond is going to be broken. Okay, so the new bonds, okay, will be joined over here. So H will come here, OH will come over there. Okay, this is addition, okay, of water. And then the condition, it must be by using concentrated phosphoric acid, and then 330 degrees Celsius and 6 megapascal. Okay, this condition must be memorized. Next, okay, so I'm taking as example HCl, for example, HCl, HX, okay, concentrated and room temperature, okay, RT is room temperature. So if I have a carbon-carbon double bond and I react with HCl, the carbon-carbon double bond is going to be broken, and you are going to have, okay, one of the H will come here, Cl will come over there. That's it. Okay, so this happens, okay, with concentrated HCl and at room temperature. So this one must be memorized. And the last one, okay, I'm taking maybe Br2 as an example. Okay, so if I have C double bond C, and when I react with Br and Br, I am going to get C like this. The double bond is going to be broken. So you put the Br here, Br over here. This is going to be aqueous, okay, and room temperature. This one you memorize, but there is a difference for this, okay. If you compare with the reaction with alkane, reacting with Br2, you are going to get something like Br plus HBr. What is going to be the difference? Okay, the difference is, okay, this is going to be aqueous and this is also aqueous. So the color is going to be orange or brownish orange, okay, or I'll just take it as orange. Okay, the orange is going to become colorless over here. The same here, orange is going to become colorless over here. But the difference is, okay, this happens super fast. This happens super fast. This is going to be slow with the presence of UV light and sunlight. Okay, so this Br2 can be also used as a test to test for carbon-carbon double bond. So if you want to differentiate ethane and ethene. What is the best option? What is the best region that we can use to differentiate them? You can use Br2. Okay, that is going to be one of the best method to differentiate them. Okay, so now you see the conditions. Okay, I'll recall, put it again. Okay, H2, the conditions that you need to know is going to be nickel at 140 degrees Celsius. Concentrated phosphoric acid, okay, 330 degrees Celsius, 6 megapascal. This is going to be concentrated and then it will be at room temperature. This is aqueous and then room temperature. Quite easy to remember. Okay. Now I will move on. Okay, to the mechanism. Okay, what kind of mechanism is this? This is going to be electrophilic addition. Okay, I will teach you how to draw the mechanism of the reaction because they will ask you to represent this in a form of mechanism using curly arrow diagram. Curly arrow diagram. So I'll introduce to you. Of course, we will discuss this further. Okay, so if you have carbon-carbon double bond, okay, if you have this, when I'm going to react with HBr, it's better to write it down as, rather than writing it this way, you write it down in this way. Now, HBr is polar. Okay, so Br is more electronegative than hydrogen. They will attract the electron. So you see the electron will go towards Br. So you see the curly arrow, first curly arrow going towards Br. And this is going to make this Br to become partially negative and this is going to be partially positive. So what is going to happen next is going to be heterolytic fission is going to happen. You will get H plus and you will get Br minus dot dot heterolytic fission. What is going to happen next is going to be electrophilic addition. So this is going to be the electrophile and it is going to be electrophile is going to be attracted towards the double bond. Okay, but when you draw the curly arrow, you draw from the double bond to H plus. Why? The curly arrow shows movement of electrons. So the electrons are in the double bond. Okay, so always remember curly arrow starts from electrons. Okay, starts from electrons. So once they attack the carbon-carbon double bond, you are going to have the formation of this H will come here. And since the double bond is broken, the electron will go to form the bond over here. So therefore, this part is going to become positive. Okay, a carbocation will be formed. Okay, a carbocation will be formed. And now, okay, you have Br dot dot. Okay, so this is a nucleophile actually. Okay, they are attracted towards positive. Okay, so electron will move towards here. Okay, you see another curly arrow. Okay, from the Br minus to the plus, and they will form BRH. So this is going to be the mechanism of the reaction. Okay, for the addition for HBr. Now, I will show you similar reaction for Br2. Now, Br2 is going to be slightly different. Why? Because Br2 is going to be non-polar. Okay, so how do they become partially positive and partially negative? This one can be explained whenever you have Br2, they come closer to carbon-carbon double bond. They are going to be approaching something that has a lot of electron, and electron will repel electron. Okay, so what happens? Because they are approaching some this molecule which is going to be having more electron, the electron from here will tend to go towards that side. Okay, so making this to become partially negative, making this partially positive. Okay, but they don't break first. Okay, they don't break. Okay, so here it's going to be partial. Okay, it's going to be partial. So if you have that, okay, the what is going to happen next is going to be the positive, the partial positive. I'll just put it here. The partial positive, they are going to be attracted towards the double bond. So they will form, the bond is going to be broken and then you will have Br, okay, this is positive. So once they attracted over there, so this one just now I show is delta negative. So Br minus dot dot will be there. And now what is going to happen? This one will go in, similar like what we had done earlier, and you will get this molecule. So the difference here is one of it is polar, another one is non-polar, okay, but the mechanism is still the same. So I want you to remember about this curly arrow diagram. I will repeat this again tomorrow, okay, so no need to worry so much on this, okay, but yeah, we will do a worksheet also tomorrow on this. Any question before I end? Donna, any question?
No, sir.
Okay, I will pass to Miss Andrea. Hold on. Okay, guys, see you. See you, Miss Andrea. Thank you.
Bye, sir.